Well, I've been talking about slope, and let's bring all this together now. An equation of a line, when it's written in this form, y equals to mx plus b, it's written in a linear function form, where y is a function of x. And it turns out that the coefficient of x, which is represented by the letter m, is the slope. And so m is slope, and the constant that's added on here is the y-intercept. Okay, now this only works when the left side is 1 times y. Solve for y. So this canonical format is called the slope-intercept form. And it's the easiest formulaic way of representing the equation of a line. And in my opinion, by far the most superior, because this gives us the most important information about a line. Now, let's take a moment and go back to ancient Greece. Euclid said that between any two unique points, there is a unique line. And so now, Euclid built his geometry on 5 assumptions called postulates or axioms. And one of those axioms is that if I give you 2 points that are different, then there's a single unique line that connects those 2 points. We can't prove that. It is so basic and fundamental that we agree that it's self-evident. It's always true. It seems to make sense, but we don't have the language with which to prove it because it is so fundamental. All right, so that's what an axiom is. It's some assumption that we think is just self-evident. And we try to get by with as few of those as we can in mathematics. Well, Euclid said that this axiom about 2 points. Well, I kind of like to expand this a little bit. You might say that it takes 2 pieces of information to describe a line. And if I know one location point on a line, and I know what direction it's pointed in, then that describes a line, doesn't it? And so that's the slope-intercept form does precisely that. There are 2 unknowns here, the coefficient of x and the additive constant, which can be a negative number. These 2 numbers are 2 pieces of information which can describe a line, slope and y-intercept, which is location and direction. So and it turns out these are of a lot of interest when we apply mathematics with linear functions. These are probably the two most interesting features about a line. All right, so y equals mx plus b is slope-intercept form. Now, once you know how to work with slope, then if your line is written in slope-intercept form, then you can just graph it quite quickly. And so, for example, let's graph y equals to 2x minus 3. Okay. Well, my slope is what? It's the 2. And so slope equals to 2. And we're going to think of slope as a fraction, so think of that as 2 over 1. Okay. And then I'll elaborate on that in a minute. The other number, the negative 3, is the y-intercept number. So let's take that information and use it to draw the graph. And I need to make a little room here to draw my nice big beautiful graph. So it starts, in a sense, not starts, but it crosses the y-axis at negative 3, because that's the y-intercept. And the slope is 2 over 1. So that means that I can generate more points on this graph by applying the slope value. So by going up 2 units and right 1 unit, I can form a new point, because the increase, the change in the y is 2 units, that's positive, so I go up now, and then 1 unit to the right on the run. And if I go up 2 over 1 again, there's another point. So I can generate these points all day long, and they kind of move up in a stair-step fashion. Up 2 over 1, up 2 over 1, up 2 over 1. That's what slope is telling us. So connect the dots, and we have a line. But I'm not quite done, because I need to put a couple of scale numbers in there so that the reader knows what to do, how to read it. All right, so there's your applying slope and y-intercept to draw a line. Let's do one more. Now, with this information, I can write the equation of that line. And the equation would be y equals to the slope number, minus 2/3, times x, plus the y-intercept number. Now I'm going to mention this in the next section's videos again, but just a little quick note here. A mistake a lot of students make, they like to write fractions this way, which is okay, but be very careful, because if you write this like that, where's the mistake? X is in the denominator, isn't it? You may not intend it to be, but if it looks like it's in the denominator, then you're going to lose points. I guess you could fix it this way, but by separating it by parentheses. But I would just recommend try to get in the habit of writing your fractions in a vertical way, and make sure that the x does not look like it's in the denominator, because that's wrong. All right. So we'll graph this line. The y-intercept is 4. So we'll put it up there. I could do a little better job with my axis here. Let's see. Okay, that's perhaps a little more even. And the slope is negative 2/3. So I have my point, my y-intercept at 4. And if I drop down negative 2 and go right positive 3, then I've used my slope of negative 2/3 to generate a second point, and then connecting these points forms the equation of the line. And again, we want a couple extra numbers on there so anyone could read the scale. And I'm going to erase this now so it's a little cleaner. Okay, there's our equation of the line.